Bismillahirrahmanirrahim. I welcome you all in our today's online session. Hope you all are fine and having good health. We start our today's session with the words of Holy Quran. So we are discussing about in previous session the abnormalities in power systems, the overcurrent causes, ground potential causes, impacts and surge voltages impacts that are produced in our power systems. So we moving towards further the analysis of power system, the types of fault in shunt aspect. So if three lines or phases are combined with each other, that is a three-phase fault. And if two lines, line to line, are combined with each other, then it becomes a line-to-line fault. And if a line connected directly with the ground, this fault is called line to ground fault. Okay, the another and last category of fault is that if two lines combine with the ground, it's called line to line and ground fault. From this one to this one is called the unsymmetrical fault, and this category of fault we call symmetrical fault. Another category of symmetrical fault is that if another category of fault is that if three lines combine with the same location each other and then connected to the ground, that is also known as a symmetrical fault. And that symmetrical fault is a second category of symmetrical fault, that is three line to ground and three lines fault are the two category of symmetrical faults. Okay, further the balance versus unbalanced condition. And what are these? The balance condition of the system is the phase 1, phase A, B and C have a phase sequence, each other is in symmetrical aspect, and the phase difference of angle is in between the phases is 120 degree apart. Further, the unbalanced condition, this condition is in nominal and normal operation condition, in which the fault is not created and our system is running in nominal parameters without fault conditions. But if a fault occur like this category, then the normal condition would be changed by this condition. That means the phase angle would be disturbed and it will look like that, become this one in unbalanced condition of the system. So the phase angle of 120 degree would be disturbed, and the impact we also observe in our appliances of even a power appliances. Up till now, if anyone of you have any kind of question or difficulty, please discuss. I will answer the kind of question and resolve your queries if you have in your mind. I think all the things are clear in your mind, and if you have no kind of question, then I will explain this concept. So the picture already I explained you guys that okay. If three phases, that is the symmetrical fault, three line fault, line to line fault, line to ground fault, and double line to ground fault if are occur, then what are the conditions that would be look in the picture that two lines are combined in this way, then we can say a line to line fault. And other system are in nominal operation, but they are also disturbed. These operation would also be disturbed. Impedance would be changed and other parameters would also be observed a disturbing condition. That is the short circuit calculation fault type single phase to ground fault. Okay, in this aspect you can see. आसिफ भाई क्या कर रहे हैं आप? ये रिकॉर्डेड चल रहा है, मतलब हम यूट्यूब पे इसको अपलोड करेंगे। और मतलब 7वां साल हो गया आपको, मतलब ये चाइल्डिश कंडीशन आपकी कब खत्म होगी? इसे सही करें, खत्म करें इसको। अच्छा। We further moving towards the next category of fault, that is the line to line fault. And before that we are discussed about the line to phase to ground fault, and here we are discussed about the line to line fault. So in this category, we can say the two phases are combined with each other and the fault is created. So in this category, in third category, short circuit calculation would also be observed. The further one phase, second and third combine with each other, that would become a short circuit, and we can say it's a symmetrical fault. So these are the three category of faults. So frequency of types of fault. Frequently fault occur would be single line to ground fault. In 80% occurrence would be done in nominal conditions. Line to line fault occur in 8% of normal practices, but double line to ground fault occur in 5% of the practices. And three lines combine in the single location, that percentage would be 2 or less percent of that. So occasionally the fault would be occur. Out of these condition is single line to ground fault, that most of the time it occurs in the utility of expect, and fault would be observed by the different kind of load, different kind of persons in different locations. So these are the frequently uh, occurring of faults in different kind of conditions. So frequency of fault occurrence, that overhead lines in 50%, if the lines are in overhead that are not covered cable, so cable fault are 10%, switch gears are 15%, transformers are 12%, CTs and PTs are 2%, control equipment are 3%, and miscellaneous other types of faults would be 8%. So out of that, overhead line occurrence of fault frequently are 50% out of other one. So symmetrical fault, how it would be occur, that three phases are combined with each other, then a symmetrical fault would be occur. Another category of symmetrical fault, which I already told you guys, that a three phase subsequently combine with each other to the ground will become a symmetrical fault of second category. Now moving towards the unsymmetrical fault in pictorial representation, that face-to-face fault, that two phases are combined into a single location, is called the first category of symmetrical fault. Now moving towards the second category of unsymmetrical fault is that the two phases are combined with each other towards the ground, is called the second category of unsymmetrical fault. The third category of unsymmetrical fault is that the single phase to earth making of this fault is a third category of fault. And what is the fourth category of fault is I think it is not mentioned here, but what is the fourth category of fault? Can anybody of you tell me? What will be the possibility of fourth category of fault? Can anybody of you tell me what is the another fourth category of unsymmetrical fault?
Sir,
ठीक.
sir, three phase.
अच्छा, थ्री फेज का जो फॉल्ट अकरेंस है वो इस सूरत हाल में, लेकिन ये सिमेट्रिकल है, और या तो वो थ्री फेज मिल जाए तो सिमेट्रिकल, और थ्री फेज मिलके ग्राउंड हो जाए तो ये भी सिमेट्रिकल, लेकिन ये दो कैटेगरी में आता है। जैसे चौथी कैटेगरी कोई भी नहीं है, ठीक है, ये तीन ही होती है। पर ये सिर्फ एक जगाने के लिए सवाल था, आगे चलता है। ओपन सर्किट फॉल्ट्स आर if a single line is open in, and other two phases are in nominal condition, it's a single phase open circuit. And two phase open circuit is the two circuits of individual phases are openly operate, that is called the open circuit fault. And three phase open circuit are the single individual phases are separately open. In this way we can say it's an open circuit fault in a single three, in a single double and three phases. So consequently, up till now, if we are also discussed about the fault condition, fault occurrence, open circuit, short circuit aspects, up till now, any one of you, if have any kind of question regarding today's session, please discuss. I will answer the kind of question, and hopefully all the things are clear. So I continue the session. Equipments and number percentage of the total fault, that is overhead lines, which is fault occurrence would be 50%. We already discussed in uh, previous statistics. So causes of faults are lightning stroke, which are the overhead faults, earthquakes, icing, birds, branches, which are the most essential and fault condition occurrence, kite strikings, patang phas jati hai. Further, kite striking, after that, internal over voltage. Okay. Internal over voltage also, all the parameters are the causes of 15%, 50% overhead lines of fault. So after that, the second category of condition in fault is 9%, that is the underground cable. So underground cable fault is a very challenging aspect in all over the region, and it is not a simple way to identify where the fault occur in the underground cable. It is a very challenging aspect, but rarely, it is not occasionally occur that most of the time underground cable would be occur. So it is occasionally, sometimes would be kind of underground fault would be occur. So what are the causes? Damage due to digging. आप जब उसे खोद रहे होते हैं उस वक्त आपने कोई चीज मार दी, उससे खुरच गया लेट से, उससे फॉल्ट अकर हो जाएगा। इंसुलेशन फेलियर ड्यू टू टेम्परेचर राइज, के ओवरलोड ओवरबर्डन के नतीजे में वो जल जाए तारें और उससे फिर फेलियर की अकरेंस होगी। फेलियर ऑफ जॉइंट्स, कि अगर आपने उसमें जॉइंट डाले हुए हैं तो जॉइंट ओवर वोल्टेज पे या नॉमिनल कंडीशन से परमिसिबल लिमिट से ओवर अगर आप चले जाएं तो वो जो जॉइंट्स होते हैं वो आपके फेलियर का बायस बनते हैं, पिघल जाते हैं, आपस में मिल जाते हैं तारे तो दूसरी वायर से फेजेस की, तो वो फॉल्ट का बायस बनते हैं। फर्दर ऑल्टरनेटर की अगर हम बात करें, ऑल्टरनेटर दैट इज 7% स्टेटर एंड रोटर फॉल्ट्स जो कि इक्विपमेंट फेलियर का बायस बनते हैं, और इनके अंदर अमूमन हिस्टेरेसिस इफेक्ट होता है ओवर लोडिंग के नतीजे में, इंसुलेशन फेलियर के नतीजे में, और जो आप डिफरेंट काइंड ऑफ इंसुलेशन इन बिटवीन द कॉइल लगाते हैं उनके फेलियर के नतीजे में, ओवर वोल्टेज और ओवर करंट के नतीजे में ये फेलियर का बायस बनते हैं इन स्टेटर एंड रोटर पार्ट्स इवन। फर्दर इक्विपमेंट्स ऑफ ट्रांसफार्मर 10% इसमें ओकेजनली फॉल्ट अकर होते हैं, जो कि कॉजेज आर इंसुलेशन फेलियर। इंसुलेशन जो कि आपने इन बिटवीन दी कॉइल, कॉइल टू कॉइल लगाई हुई है, और एग्जिस्टिंग कॉइल के अंदर लगाई हुई इंसुलेशन जो कि आपकी वार्निशिंग होती है वो बाज़ वक्त पिघल जाती है, पुरानी हो जाती है, और फॉल्ट का बायस बनती है, लीकेज का बायस बनती है, और उससे आपका हिस्टेरेसिस इफेक्ट जो है डैमेज होता है, और फ्लक्स लीकेज इसके जरिए होता है, और बाद में फिर बड़े बड़े मसाइल इससे पैदा हो जाते हैं। इसीलिए उसको ऑयल इमर्स किया जाता है ताकि वो उसकी जो इंसुलेशन है वो मेंटेन रखी जाए, ये भी एक रीजन होता है। फर्दर फॉल्ट इन टैप चेंजर्स, टैप जो आप चेंज कर रहे होते हैं, देयर आर टू टाइप्स ऑफ टैप चेंजर्स, ऑन लोड टैप चेंजर्स एंड ऑफ लोड टैप चेंजर्स। सो इनकी टैप चेंजिंग के नतीजे में, और ख़ास तौर पे जो लोड चलता हुआ जब आपका होता है ऑन लोड टैप चेंजर्स इन सब स्टेशन ग्रिड स्टेशन, उसमें आपकी जो फॉल्ट्स होते हैं बाज़ वक़्त स्विचिंग के नतीजे में अकर होते हैं, आर्किंग स्पार्किंग उनके नतीजे में होती है और वो ट्रांसफार्मर फॉल्ट्स की कैटेगरी में आते हैं क्योंकि टैप चेंजिंग ट्रांसफार्मर में ही होती है। नाउ मूविंग टुवर्ड्स दी ओवरलोडिंग जो ट्रांसफार्मर के कॉजेज ऑफ फॉल्ट्स का एक बड़ा बाइस है कि आप ट्रांसफार्मर के ऊपर एक्स्ट्रा ऑर्डिनरी लोड चला रहे होते हैं जो डिस्ट्रीब्यूटिंग स्टेशन के ट्रांसफार्मर्स होते हैं, और इनके नतीजे में आपके जो ट्रांसफार्मर्स का जो इम्पैक्ट होता है वो काफ़ी हद तक मुतासर होता है और फॉल्ट का बाइस बनता है। Moving towards the instrument transformers, there are two types of category of instrument transformer, that are current transformer and potential transformers. And the fault occurrence in the instrument transformers of CTPTs are 12%. So what are the causes of faults? Over voltages and insulation failure, break of conductors, wrong connections are the main reasons of the causes of faults. Now moving towards the another category, switch gear of equipment as a substation grid station, and switchgear drum is dedicated with the LV side of circuits, and switch yard drum is dedicated with MV medium voltage circuits, and high voltage, extra high voltage and ultra high voltage drums is dedicated with the switch yard, and switch gear is related with low voltage. That is, the fault occurrence in the equipments are 12%. And what are the causes? Insulation failure. So mainly insulation failure is essential and important aspect. So insulation, if you insulate a particular conductor, coil and other kind of things, you need to be very careful for its insulation, because insulation failure are most of the time create a vital role for a causes of faults in most of the network of circuits in power system. Leakage of air, oil and gas, switchgear, and mechanical defect, lack of maintenance. So these are also the causes of faults. Further, the decomposition of an unbalanced system. I already told you guys the sequencing equipment, sequencing parameters. So you need to be too much careful to understand this thing, that zero sequence single phase. So zero sequence single phase is that all the sequence in between the phases are zero. That means the creation of angle, which is the phase difference, that is 0, 120 degree and 240 degree. The 120 degree apart of each other, each and every of phase is null and void in this aspect. So the phase difference should be there, and if the phase difference is zero, then that particular sequence is called a zero phase sequence. So positive phase sequence is that a system is in balance mode is be called a balanced phase sequence. That is a positive phase sequence. Every of phase of current or voltage respectively would be a phase difference of 120 degree each and every phase of each other. Similarly, a negative phase sequence change a rotation of phases, that A1, B1, C1 and A2, B2 and C2. This is the negative phase sequence. That is the opposition of this sequencing symmetry. So most of the time we prefer a positive phase sequence, but negative phase sequence is not too much popular in power systems, but it's a category of sequence. Okay. After that, if a fault occur, these are the balance system, balance, and this is the starting of signal, but single phase. But if a fault occur in system and system become unbalanced, so what is the consequences which is appear in phase sequences? So that phase sequence would be disturbed in this way, from this one to this one, or from this one to this one. So we can say it's a balance phase sequence which is in from balance to disturbance aspect. So this is the decomposition of system from balance to unbalanced. So this one we call say unbalanced phase sequence of a system, in which a first phase is IA, second phase is IB, and third phase is IC, and the phase difference in between them is anything. That would be 10, that would be 20, that would be 140. So it is unpredictable in unbalanced mode. Up till now, anyone of you, if have any kind of question or query regarding session, please discuss. I will resolve your queries and answer all the kind of your question. If you have the kind of question or query, please discuss. Hope all the things are clear. So we moving towards the fault minimization. What are the uh, preventions that we need to follow to minimize the fault aspect, fault level, to improve the quality of machines, equipment, especially about the insulation, installation, etc., by improving the design techniques to design the system in the improved techniques. So fault level would be minimized in this way. Adequate and reliable protection, system control, and regular maintenance by trained professionals. So this is the one of way. Effective management of electrical plant. So by this way, you can also be prevent your system by fault, and your fault level would be minimized by these steps of proceedings. After that, the merits of fast fault clearing helps to avoid permanent damage to equipments and components of apparatus. So if we protect our system by preventive maintenance and preventive steps that as per demanding SOPs, then fault minimization would be prevent the system from damage. Reduce the chances of risk like fire hazards. If we minimize the fault level, then the chances of fire hazard would be reduced or minimized, you can say. Maintain the continuity of power system. So the consistent and uninterruptible power supply would be provided by the utility if the measures can be followed. That is mentioned in the slide. Now moving towards the last point, bringing back the power system to the normal state sooner. So further the contribution to faults. So short circuit to the source of fault current. So in this picture, it is divided into four sections. Number one, turbine generator, and further the flow towards the short circuit in different sections. And the driving aspects are the synchronous motor, induction motor, and further utility of system that is driven by the system as well. So turbine of generator, that is one level of short circuit current from generator that is inside to the system, the metal plate switch gear, which can get the supply and also distribute the supply in different kind of load, different kind of utilities, different kind of tariff of industrial, commercial are also driven by this aspect of techniques. So we need to understand the parameters and the flow of power that is incoming from this side, provided to the switchgear of panels, and further distribute in different directions that you can see of flow. Second category, a short circuit current comes from the synchronous motor. If a short circuit comes produced, that would be short circuit produced, and that would be arrow direction you can see into the system of switchgear. That is the in panel form. So if fault current or short circuit current would be produced in generator, so it will be in to the system by in this direction. So, and another category of fault causes would be if any kind of condition aspect that create a short circuit current in the induction motor, then also produce a short circuit current, and in third category of aspect to the switch gear of panels. After that, from a utility, if a short circuit would occur in the transformer and other kind of parameters and conditions, that short circuit current from an electric utility system would also be into the switch gear of panels. In this way, so in switch gear of panels, the protection equipments have to be installed to prevent the system, consequently, the fault from existing to another interconnected way. And if they are not interconnected, linked by series of way, so we have to be prevent the systems by the short circuit to the protective relays. Either they are the protection equipments like protection relays, circuit breakers, and other kind of categories. And in last, the total short circuit current from all the four aspects would be summarized in this aspect, in this cross aspect. So these are the consequences of short circuit, sources of short circuit current, fault current that has produced and also disturbed the causes of this thing. uh, I think all the things have been clear in your mind up till now. Any one of you, if I have any kind of question or difficulty, please discuss. I will answer the kind of question and resolve your queries. If it's in your mind, please ask. So this is the reading part of today's session, which I am sharing with you guys. And I'm leaving today's session after this slide. So you can read by yourself and leave the conversation one by one. And I'm ending the session in this way. If you have any kind of question, please ask. And further, we will end the session after all the things.
Recording in progress.
Hopefully all the things have been clear in your mind.